Okay, so we just spent some time talking about horizontal asymptotes. We're going to back up just a little bit and kind of talk about what horizontal asymptotes are a type of, which is end behavior. So we'll start with a quick definition here. The behavior of f of x, and by behavior we mean what the graph is doing, what the y values are doing. Okay. As x approaches infinity, and x approaches negative infinity is called the end behavior of the function. So you've heard this term before. In fact, we talked about it in lesson 2 when we reviewed functions. But this is a slightly updated definition for you because you didn't know what it meant for x to approach infinity or negative infinity necessarily in pre-calculus. So it's just kind of adding that extra calculus explanation to what end behavior is. And let's talk a little bit about what we know could happen. What are the possibilities for what a function is doing in as x approaches either positive or negative infinity? And since we just spent some time talking about horizontal asymptotes, let's list that as the first one. So option 1 is a function could have a horizontal asymptote. And what that means is that the limit as x approaches either plus or minus infinity is going to be equal to a real number. And that number will be the asymptote. But does that always happen? I mean, think about a parabola, just even x squared. What happens as x goes to positive and negative infinity in that graph? The graph just keeps going up and up and up. And then if we flipped it over and made it negative x squared, then it just keeps going down and down. So another option is that f of x increases, right, or decreases without bound as x approaches either positive or negative infinity. And so a couple of good sort of visuals for that would be something like an x squared or a negative x squared. Just something to think about to kind of give you that visual assistance. And then there is kind of a third option. I don't necessarily have to have a horizontal asymptote, but I don't have to go on for up and down forever. So think about something like y equals sine x or y equals cosine x. What's happening there? So there are these waves, and it's not going to infinity, but it's also not ever approaching a real number. And so one way we describe that is that f of x oscillates, right, between values. And in that case, the limit just plain old doesn't exist. It's not that it equals positive or negative infinity. Okay. I guess don't need to say equals, does not exist, just does not exist. There's no real number. Okay, so we're going to spend a little time going through the different types of functions we have and identifying their end behavior using this limit notation. So we already talked about polynomial end behavior in lesson 3, right? And it had to do with degree and leading coefficients. So if it was even degree, like x squared, and the leading coefficient is positive, remember that meant that it went up, right, on both ends. And if the leading coefficient was negative, that means it went down on both ends. So write that using limits. So the limit as x approaches both positive and negative infinity of your function will be positive infinity, or in the case where both sides are going down, that limit would be negative infinity. And then remember, with an odd degree polynomial, it's up on one side and down on the other. So if you remember, for the positive leading coefficient, that was up on the right. So as x approaches positive infinity, it will be up. It will approach positive infinity. And on the left, it goes down. So as x approaches negative infinity, the function will approach negative infinity. And then you're just going to flip those for a negative leading coefficient. Okay, so we've already kind of done that review, but now we're just writing it with limit form. And there's really no work to be done when you are trying to find a limit as x approaches infinity of a polynomial. You're basically just going to find that leading term. You're going to see in this case that it is an odd degree. It's a positive leading coefficient. And since you're approaching negative infinity, then that means it's going to go to negative infinity. And similarly on the next one, I have a even degree, but a negative leading coefficient. So both ends go down. So it would also go to negative infinity.